Okay. All right. Welcome everybody. Happy New Year if that's the still thing. Welcome back. Hopefully you had a great break and you're ready for the new quarter. Um, so this quarter I'm going to teach this course called Secure and Trustworthy Edge Computing Systems. We're gonna apply for a permanent course number for this, and I'm thinking about actually changing the number, making it maybe a little bit shorter. But anyway, the general idea of the class is talking about various different topics in IoT security, and the plan for today is that I'm gonna kind of give you a brief introduction of why this is an important topic and why you should consider taking this course if you're still thinking about whether or not you should take it. Then I'm going to talk about the logistics of the class, what are the expectations, workloads, etc., etc. Then if there's any questions, I'm happy to answer that. And then usually we have more time, so I'm going to actually start going over some basic topics. Okay. So to kind of start talking about this course and the importance of this course, there are kind of two main components here, right? One is the security aspect, and the other one is the IoT aspects. So why cybersecurity? Cybersecurity is kind of like one of these very growing topics for you guys. Is kind of like thinking about like most of you are grad schools or like seniors in undergrad thinking about like careers and stuff like that. I think the one area that's kind of growing significantly these days is cybersecurity. The reason for it is that stakes are much higher compared to what was like before. The reason for that again is that basically we are kind of seeing two trends I'm going to talk about. One is that we are having more and more computing devices in our lives, right? So if you think about like the various aspects of your life that maybe even 10 years ago you weren't using any sort of digital or internet connected devices, and now like many of things that you do is now using some form of computing systems and devices for it. And the second thing is that not just the sheer number, but they are actually controlling lots of critical things, right? So now it's much more interesting for an attacker to kind of attack those devices. So for example, the pictures I'm showing you here is for example, the ransomware attacks that's kind of becoming very, very common, and we're going to talk about ransomware at some point in the class. For example, this was when I was living in Atlanta. So this the picture on the right side. So lots of hospitals in the Atlanta metropolitan areas was impacted by this ransomware attack, and eventually the states decided to pay the attackers. So they actually paid about $10 million to get their data back. So what happened was this ransomware attack, which is this type of attacks that kind of encrypt the entire data memory in your system. They were infected these devices, their databases of patients' data, and for patients, for hospitals, this is very important. And what happened was they had to kind of give them the money back, give them some ransom, some money in order for them to kind of decrypt this data for them so that they can get their data back. And things like Bitcoin, unfortunately, is making these things in this transaction much more easier for adversaries, right? Because now what they can do is kind of showing this message on the left that I'm showing is that you start your computer, you will see something like this, and you have to pay them the Bitcoin in order to get your data back. And this is another interesting number here on the top, on the bottom right, that since 2018, organizations, especially on healthcare organization, in the entire world has been seeing downtime of $92 billion just because of the impact of not just about the ransom, but because the system has been down for some time and they were losing money. So, and then there are lots of statistics like this. If you actually search, there are lots of interesting documents that's kind of like every month, every few months, they report they publish reports like this, that what's the cost of cybersecurity and so on. So I mean, general in short, cybersecurity is on the rise. Yeah, you can come in. And what is happening is There are more, interesting things for attacker to attack. There are interests in terms of, either money or the influence, or even at the government level, these things can happen. And then, of course, on the defender side, now there are lots of interest in order to secure these systems, right? So that's the security aspect. I think you guys probably already interested in this. And then the second thing is the IoT side. So why are we particularly targeting IoT for this course? The reason is that IoT is kind of this growing term of really impacting many, many aspects of our life. So if you think about IoT, it's kind of like this nice picture that borrowed from on this website, is that if you think about this, is you will see some form of IoT devices in your homes, in your cars, in your transportations, in smart, cities, in manufacturing. And as I said, when we use the term IoT, although it's like more of like Internet of Things devices, but really it's kind of a blanket term that we use for cyber physical systems, embedded systems, and generally any sort of a smart device that we have that may or may not necessarily have always connected to the internet, but has some form of connectivity to send and receive some commands, okay? And the interesting thing about IoT is that, we're seeing this huge impact, as I said, the number of devices and their critical applications is growing rapidly. And the interesting thing about IoT is that it's very, very hard to secure these devices. The reason for that is they usually have like many, many layers of abstraction on top of each other. So securing a device is not just a software problem, or it's not a hardware problem, or it's not a network problem. It's actually very, very complex interaction of all these kind of different components together, okay? And there is also complexity at each different layer. So for example, if you want to just focus on the software side, or if you want just to focus on the hardware side, even within that one single layer, there are a whole bunch of things that we need to care about, right? Uh, and as a result, the attack surface is very, very large. The system can be attacked because of vulnerabilities in hardware. The system can be attacked because of vulnerability in software. The system can be attacked because of the implementation issues that we are facing, okay? And then unfortunately, the future trends is just telling us that things are going to get worse. Because we keep adding more and more devices into our day-to-day life. So we are not really kind of going into the lower direction. We're actually going to the higher direction, which means that we are more and more interested to adding smart this and smart that to our life. Homes and cars and cities and doors and locks and everything are becoming more smart. And unfortunately, on the other hand, the stakes are even going higher, right? So the future trends means that not only this is not kind of a solved problem, but this is actually a growing problem. And that's why, as I said, folks who are interested in thinking about careers, this seems to be, I think that my suggestion is this to definitely consider a career in cybersecurity, especially in like IoTs and so on. And apart from that, this is actually a very hot area for research, and it's in very high demand. So there are lots of papers coming around these issues, both from industry and academia. The cybersecurity business now is $1 trillion business, and is growing. And there are lots of interest in governments and large companies, because they are the ones who has like lots of data. There are lots of important data that they want to kind of protect. And lastly, there's like a big shortage of labor in this domain, okay? And that's kind of one of my main motivation of like teaching courses like this, to kind of like, educate students to become experts so that they can actually go and join, workforce in this domain. Particularly, cybersecurity is one of those areas that always has, shortage in terms of labor, because of the kind of the growth of cybersecurity issues significantly faster than the way that people got interested in cybersecurity. So there's this big gap that you definitely want to, again, consider, a career in this. All right. So it's kind of like the motivation of why we are doing what we are doing, and what topic that we're going to talk about. We're going to specifically kind of focus on this kind of paradigm of IoTs, and and interaction between IoT devices with some form of a cloud and some form of a user. And this is mainly, we're going to stay at this hardware software interface. So this is not like a software course. This is not a hardware course. It's very kind of software, hardware oriented course. There will be lectures more focused on the hardware side of things. There will be lectures focused more on the hardware, on the software side of things. And we're gonna basically cover most of the basics that we need. This is generally a course that's kind of like very breadth oriented, which means that we're gonna talk about lots of different things. So it's not gonna be like, oh, this very particular topic and we go very deep on it. It's designed to be kind of like giving you a little bit of various different things, okay? As a result, it's not kind of expected that you're gonna have background in all of those topics. So we're gonna give you backgrounds. We're gonna start from kind of like very, very high level and then gradually go down as we move forward. So the class format would be, I'm gonna give you lectures every week. Then it will be coupled with student presentations, paper presentations. First 3 weeks is just gonna be me, so I'm gonna just give you lectures starting from week 3 or week 4, I don't remember. Then the paper presentations will start. Usually it's going to be 3 hours of me lecturing and 1 hour of paper presentations. That's kind of going to be the format starting week 4. It's going to be less about homeworks and exams. It's mainly kind of like more self-motivated kind of course. So it's kind of giving you an opportunity to kind of learn about these topics. And as I said, it's mostly kind of breadth oriented, which means that we're not really going very, very deep in each of these topics, but it's going to give you some kind of pointers so that you can actually then, if you could become interested, go and spend a little bit more time and reading about those. I started adding, more hands-on projects. So previous version of the class, I think the first time I think this is 4th time I'm offering this. The first time I didn't really have any projects. Then I gradually add them. This year I'm planning to add more hands-on projects, but that's kind of the feedback I received last time I taught the course. So let me actually go through the logistics, kind of different components. First of all, about me, I think most of you know me, but for those of you, this is the first time taking a class with me. My name is Nader. I got my PhD in computer science from Georgia Tech in 2020. That's why I was like actually living in Atlanta at that time. This is my 4th year at UCLA, and this is the 4th time I'm actually teaching this. I taught this course every year since I joined. My research interest is mostly in security, but it's in computer architecture security and system security. So I do lots of things in IoT security as well. So many of these topics that I'm talk about is actually directly related to my research. Some of them are just, I'm interested. I'm not really doing any research on that. I have 2 cats, so you're going to see lots of cat photos. And to pronounce my name is just Nader with like an extended A. So it's not Nader, it's Nader. And my last name is basically 3 parts. It's Sehat Bakhsh. Good news is that you can just call me Nader. You don't need to be worried about my last name. Just either like people also call me Professor or Professor Sehat or Dr. Sehat. The part that I don't like is that I call my first name and Professor. So don't call me Professor Nader or Dr. Nader. But I mean, people keep doing that. So anyway. So best way to reach me at is through CampusWire. I'm going to actually talk about what is CampusWire. But for this particular course, if you have any questions or things like that, the easiest way is CampusWire, because then I know where the requests are. You can email me as well for more serious stuff, but CampusWire is the easiest way to contact me. I have office hours on Wednesday after the class, 4 to 5, just right after the class. I usually stay a little bit longer as well, so you can come and talk to me afterwards. My office is actually in the same building, Walter Hall, 6th floor. So if you actually take the elevator, come to the 6th floor. It's just right by the not right by the elevator. If you just go a little bit and then to the left, you will see my office. If this office hour time doesn't work for you, Mondays after the class also works, and if none of those 2 works, Friday afternoon is also a good time. So you can just come by, or just email me and we can schedule a meeting. By the way, this class is also offered online, so it's part of the MS Online program. So if you're watching the MS Online classes, hello. And so for you guys, the office hours would be just on demand. So if you want, you just email me and we can schedule a time. Okay. By the way, if you have any questions about any of these, feel free to ask. I'll also we have time to ask to answer more questions. For introductions, I usually use this website called Padlet. It's where you can actually introduce yourself. I already put mine there. So if you have time, please go and put your name and some photos and stuff like that there. It's usually good for us to learn about each other. I'm personally very interested to kind of get to know more students and talk to them beyond the class. So it's not just, me coming and giving you a lecture and then I leave. I really want to know what you're doing, what you're interested, and hopefully we can kind of like start, having some conversations and talk to different things after the class as well. I watch lots of sports, so I do play games, stuff, so we can actually talk about those things as well. Yeah, do this whenever you have time. You don't need to do it now, but just make sure to do it if you can. Okay. All right, so let's talk about the course elements. So there are kind of a bunch of different things. I want to break it down for you guys. And then, of course, you can always come back to this set of slides and this recording to kind of like, learn more about this. Especially for the paper presentations, it's important to follow the exact format that I'm explaining to you, okay? So components of this class is the lectures, obviously. Then there's the paper readings / presentations. Then there's some form of participation. There are going to be one exam. There will be a bunch of computer assignments, and there will be one final paper review. So let's talk about those. So first of all, as I said, the philosophy of the course is different than kind of like more traditional kind of fundamental courses that I'm kind of pick one topic and then talk about this and have a bunch of exams and homeworks and stuff like that. This is more of like an open-ended kind of, do it as you're interested. So you can spend as little as time that you want on this class or as much as time you want to put on this class, really. I think you can get by just watching the lectures and doing a little bit of homeworks and so on, and you probably will receive some form of an A or some B if you don't do well. But the rest is basically depends on you of how deep you want to go, whether you want to really do something interesting here. And then, as I said, in the middle is that there might be topics that you won't have any background on it. Don't worry. We're gonna give you some feedback. But this is totally normal because we kind of flip-flop between software and hardware, and not necessarily all of you have background on all of these things. Okay. And the rest of the components in the class, other than lectures, is kind of designed for you to kind of go deeper. So for example, the paper presentation, you have a chance to pick kind of the paper that you like. And what I want from you is kind of like spending a little bit more time and reading about that topic and so on and so forth. So among these different topics that I'm going to talk about, you have an opportunity to kind of go a little bit deeper on that particular topic of your choice, right? So that's kind of the idea. All the things that we're going to discuss going to go into the class website. As you've probably seen my post on Canvas, we're not going to use Canvas. Instead, everything going to be posted on the website, which I put the address there. And one thing that you can do is that, as I told you, this is, I think, the 4th time I'm teaching this. So if you actually change this to the previous versions, you will see the exact same for previous years as well, to kind of get an idea of the lectures and so on. The syllabus and then the schedule change a little bit every year, so don't rely on the last year's schedule. So just always make sure to watch the video of this year. But if you're interested in various different things, you can always watch those. For kind of announcement and Q&A, we're going to use CampusWire. How many of you haven't used CampusWire before? Haven't. Okay, so a few of you. So CampusWire is like Piazza, some form of Canvas as well. It's just a website that we can post questions and answer questions and stuff like that. I put the information about how to enroll on CampusWire on Canvas. How many of you haven't seen my post on Canvas? Everybody did. Yeah, so if you go there, you will see the link, you will see the join code. I've seen already people have enrolled on the Campus Wire, and even there were some questions as well. So please enroll on Campus Wire ASAP, so today, so that because we don't use Canvas anymore, so you're gonna actually miss things if you don't, enroll on Campus Wire. And then we're gonna also use Gradescopes for the exam and for the computer assignments that we're gonna provide. So basically, most of our work would be the website for all the kind of public information, Campus Wire for Q&A and announcements, and Gradescope for the exams and turning in the projects and stuff like that. Okay? Questions so far? All right. The lecture format is going to be in person, but the attendance is not required. So you may or may not decide to come to the class. Everything will be recorded and posted on the website. I usually just post them online on YouTube and then put the link on the class. Usually I do it on the same day once I go back to my office. It usually takes like 2-3 hours for the video to become available, and then once it becomes available, I put it on the website. The recordings will be on the schedule, so you will see, and if you go to the website, you will see the spec table of like different lectures. I already kind of populate the lectures, so you can actually kind of see what's going on for each week, and then you will see that kind of the link of the video will show up there. As I said, attendance is highly encouraged, but I'm not gonna kind of track who's coming and who's not coming. So I guess that means that usually like first day of the class, you see some faces and then they kind of go away and then come back at the very last class when we have the exam. But that's okay. If you think that you learn more of just watching the lectures, do it. But definitely coming to the class is helpful because you can ask questions and we can clarify things. And then, of course, follow UCLA guidelines for COVID. It probably is going to be last time I'm putting this here if I don't jinx it. But yeah, if we decided to go online, we will go online, so on and so forth, right? The syllabus is again on the website. As I said, it's kind of like a broad set of topics starting from systems and then hardware. And then the prereq is kind of basics of computer organization, okay? So that's really what you need to have. At UCLA, this is CS33, but some equivalent if you're not, if you didn't do your, undergrad at UCLA. The list is there of the topics, but it might change slightly, so things might change a little bit, but mostly gonna be based on the syllabus that I put here, all right? All right, so there will be paper readings. Hello. And these are optionals. That's another change that I made this year. So last year, the paper readings was required, which means that you had to read it and you had to write a review for it. But thanks to ChatGPT, this no longer is a proper thing to do because it's basically 5 minutes work with ChatGPT, and I'm not gonna go through and see whether you copied from ChatGPT or not. So as a result, I made it optional. If you really want, read it and maybe write a review for yourself, or don't. Again, this is based on you and how much you want to really work and put time on this course. The paper list is again on the website. If you go in the week 1, you will see kind of like the link to the papers. This paper is going to be presented in the class, okay? And of course, those that present the paper probably gonna read the paper first. Everybody else, again, I definitely recommend you to read the papers each week, probably before the paper presentation, so that you can actually get some idea of what's going on during the presentations, but you can even like read it after a little bit as well. And then these papers are mostly selected from top tier conferences in security. So in security, we usually have 4 top, conferences called CCS, Usenix Security and Privacy, or S&P, and did I say CCS? Oh, and NESS. So you will see that most of these papers are first selected from there, but there are like few other, venues that also like, they publish good, security papers. So some of them were selected from there. As I said, no need to write a review for this, okay? I also put a link here for this very nice article about how to read a paper. This is actually very helpful to kind of get you an idea of like, if you have a bunch of different papers each week that you need to read, what's the right strategy to going after. So for many of you, this might be the first time or the first few times that you are actually reading papers. So I recommend first reading this before reading anything else. This gives you kind of an idea of what's the right approach. And then another recommendation that I have when you're reading these papers is that, again, these are very deep papers, okay? And these are tough papers, lots of things that you need to know in order to fully understand it. But hopefully with watching the lectures or watching the presentations, you will get the basic idea, and then you can kind of understand most of the paper. But it's okay that, again, you don't understand everything about the paper. And don't kind of like, kind of stuck in the paper for like 8 hours trying to understand everything about it. The idea here is that you want to understand like 75%, 80% of the paper. And if you understand 80% of the paper, you're good for this class. And again, for those topics you're really interested, that's where you're going to kind of cover that 20% gap. And for that 20% gap, you need to read lots of other things in order to understand that like remaining 20%, okay? So paper presentations, this is an important part of the class, and this is the part that's kind of like everybody will enjoy if you do it right. So it's kind of like those community things that if everybody does it right, everybody will benefit from it. So the way it works is that, each week we have between 3 to 4 papers to present. It will start from week 3 or 4. Again, I need to check the schedule. Each person has to present at least once during the quarter, okay? But since there are many of you and there's like less papers and we don't have time for each person to individually present a paper, we're gonna do it in groups. Usually we do it in group of 3, sometimes 4 if you really need to. But like I think for now, 3 seems to be the number based on the number of people that we have in the class. If you're planning to not take the class or not hold the class, please don't sign up to any of these groups, because what will happen is that you're part of one group and then you kind of drop the class and the other people in the group cannot, because once we set all the groups, we cannot change them, okay? So just make up your mind that you're gonna whether take this class or not, and do it as soon as possible, please. I mean, of course, you can still, drop the class, but that's on your group members. So if you are in a group that some or all of your team members have dropped and it's only you still have to present the paper alone or something, okay? Of course, I'll be a little bit more flexible if there are less number of people, but just keep that in mind. Okay, if you don't know your group or you don't know people, that's fine. You can sign up and then I'll form a group for you. Okay, so the way it's going to work is that there will be a sign up sheet. I don't know if you have a slide for it or not, but the sign up sheet is already on the website. If you click on the sign up sheet, you will see a Google form that you have to write down your name and select the papers that you like. Okay. And if you will see, the papers are kind of in different categories, and there's like paper numbers. And so that's basically based on the paper list that I provided here. Okay. So if you go here, this is the paper list. You will see the paper list here. Decide which papers you want to select. Probably the idea would be the topics that you think you're more interested in, the timing, whether you're busy or less busy, end of the quarter, beginning of the quarter, whichever. So think about all those things and then select at least 4 different papers that you want to select. Okay. Once you do that, if you have a team member, just one of you needs to kind of submit the form. Not all of you needs to submit. Just one of you submit, and then just write your team name, team members. If you're alone, or there are like 2 of you, or there's like 3 of you, but you need one more person and so on, just put your name down. I'll do the grouping for you. Okay. So yeah, so this is what we're gonna do. So the presentation format would be kind of 10-minute-ish. Okay, so each paper presentation should be around 10 minutes. Don't go over that. I'll give you a little bit more details in the next slide. And then again, for Master Online students, you will also have to present a paper. Your paper will be different because you have to record yourself and then submit the paper, okay? And since there's only 9 or 10 of you, you have to do it alone. So the group thing doesn't apply to you, all right? So again, I'll give you the sign up sheet for paper presentations. All right. So what is the goal of the presentation? The goal of the presentation is for you to go a little bit deeper into that topic of your choice. Okay. And not only that, these also kind of give other students of like a little bit of like overview of what's going on, right? So as I said, probably not all of you are going to read all the papers. So the part of the lecture which is done by you is teaching other students of what's going on in that particular paper. That's why I am emphasizing that, you know, if you're doing a good job on your paper presentation, not only you will benefit from it, but other people will benefit from it because they can actually learn something from you. Okay? So take this very seriously. I'm going to also very rigorously grade this. So spend a lot of time preparing and learning and so on and so forth. Okay? So you're going to be judged on two things. One is the content of your presentation. And the second is the presentation itself. Whether you're well prepared, you're using nice graphics and so on and so forth. Right? And then as I said, low quality presentations is going to impact us all because it's going to be very boring. Nobody will understand anything. So just all those things that you didn't like when there was a faculty kind of presenting and you didn't like, try not to do that, right? So yeah, make it both like very exciting in terms of visuals and the content. So I think I covered these. And then another good objective of this is that you kind of like practice your presentation skills. Because what I notice is that many of us are lacking that kind of expertise. And then soon you're going to graduate and you have to present almost every week to some other people, right? So if you can do it well, trust me, even if you may not know the content very well, but you're a good presenter, that's going to go a long way in many, many, many different industries. All right. So kind of practice on that. And then what we want from these paper presentations is giving very, very high level idea to other people as well. Okay. So that if you come to the class and you listen to someone else's presentation, you get something out of it. Okay. And then, of course, this also gives you an opportunity to kind of learn a little bit more about each other and kind of do the networking and doing grouping. So, for example, if you're coming with knowing nobody in the class, this at least gives you an opportunity to at least know two more people, right? So these are the guidelines, and as I said, you can actually refer to these guidelines whenever you have your presentation. I'm going to very quickly go over it. Make it 10 minutes long. Don't make it more than that. You will lose point if you do. Skip any sort of motivation or introduction because usually the idea is that I already gave you the introduction during my own lectures. So the paper presentation is kind of the next step. So don't start from like beginning of why, for example, IoT matters or why security matters, stuff like that. So usually the best way to do this is that your first slide should be the specific problem that's trying to be solved in that paper. Okay. Then your next few slides should be some form of background that hasn't been covered in the class, okay? So keep in mind that lots of these things that when you're designing your presentations already been covered in the class. So build on top of that. Don't just repeat the things that have been said in the class, okay? And then another thing that you should do is that don't just repeat everything in the paper. It's also I want to see your take or your understanding of the paper because many people have read the paper already familiar with the paper. What you need to do is kind of like, you know, giving us a little bit more perspective. Maybe reading a little bit more about other relevant papers and give us a little bit deeper background, give your kind of understanding of the paper, things like that. So don't just repeat, okay? And then again, connect what was taught in the class with what is in the paper. So for example, in the class, maybe we talk about a simpler scenario, and this paper is talking about much more complex scenario, right? So connect these things so that people kind of understand, oh, what is the relationship between this paper and things that we have been taught, all right? So then after kind of giving the background, then describe the solution. Try to stay at the intuition level rather than really going to the nitty-gritty of like how this things has been implemented because this is only 10 minutes. And again, this is just to give people what's going on. So give us the big picture, not the details. Whoever is interested in the details, they should go and read the paper. Okay. And then don't talk about, oh, these are the experiments they run. This is like the, I don't know, software they use, stuff like that. Again, those are details that people can go and read. Just give us the general motivation, the general outcomes of the paper and things like that. Okay. So give us insight rather than the kind of details. And then I want you to kind of end the presentation with some form of a slide that's talking about what are your thoughts, what are the weaknesses, strengths, discussion points, things like that, questions, anything that you think can kind of instill some sort of discussion, either in the class or through Campus Wire. Okay, so make it more of like that. Any questions so far? All right. So participation is optional. You can participate in the class by asking questions. One thing that I really want you to do is asking the presenter questions and kind of like start having some discussion, or at least giving you your kind of take from the paper. And on Campus Wire, also you can do all these things offline. So if you're not coming to the class or just watching the lectures, or you don't feel like asking questions during the class and so on, you can actually ask them in Campus Wire. And what I want you to do is answer those questions as well. So not just asking, is answering is also important. And everything, by the way, on Campus Wire is completely anonymous, which means that I don't see what you're posting, I don't see what you're asking, and I don't know who asking and who is answering. Okay, so just feel free to share your thoughts. It's completely anonymous, so no judgment. Okay. Uh, so we're gonna use campus reputation points to give you bonuses. Okay, so this part is just completely optional. Your reputation points at Campus Wire is that if you ask questions or answer questions, you're gonna get some points, like 2 points for asking a question, 4 points for answering, stuff like that. The way I'm gonna give you bonus point is the first person, like the highest reputation point, is gonna 3% to the overall grade. Gonna just add it directly to their final grade, whatever it is. Then the 2 to 5 gonna get 2%, 6 to 10 gonna get 1%. Okay. And I don't know, if the first person is 1,000 points and the second person is 999, that's how we're gonna do it. If the first person is 50 and then the other person is 49, that's how we're gonna do it. Okay. Uh, and then so the benefits is that you get to ask questions, you get come to the class and staying up to date. And then again, if you want to make a good impression in me, coming to the class and asking questions and become active in the class, generally that's how it works. Okay, so if you think about like doing some sort of research, looking for recommendation letters and stuff like that, I'm telling you right now, this is the way that you're gonna get these things from me. Otherwise, if I don't know you, my answer would be no. Okay. So there will be one exam. There's also another minor change that I made from last year. There used to be two, and now it's one. It's going to be on the last day of the classes. Okay. So Wednesday of week 10. There will be no rescheduling options, which means that if you're traveling or if you have other plans, cancel them or drop the class, either of these two. I cannot make any changes to the time of the class or schedule of the exam. The main goal for the exam is to kind of like make sure that you watch the lectures. It's going to be mostly like high level, okay? Questions, and then we usually have kind of like true or false questions and some high level questions. I'm going to share with you the kind of some samples of last year. So it will be based on materials that we discuss during the class and the presentations, which because presentations are also part of the lectures, but not directly from the papers. Okay, but the important thing is that it's going to be open book and open notes, so you have access to all the lectures and you have access to all the papers. You don't need to memorize anything. It will be an in-person class, except for the masters online students who will do it on Gradescope. For them, they have 24 hours to take the exam, so they're a little bit more flexible. Yeah, multiple choice and questions, short answer question, open-ended questions. These are the type of the questions you're going to see in the exam. Okay. Computer assignments, as I said, another thing that I changed this year is I'm adding more computer assignments. I'm thinking about doing 5, but let's see how it goes. There will be one on cryptography, which I'm gonna start talking about cryptography end of this week, starting next week. There will be one on side channels, one on blockchains, one on binary analysis, and the other one would be on some form of binary analysis tools. For all of these, you need a little bit of basics of programming, but it's okay if you're not familiar with any of these tools. The submission would be on Gradescope, usually going to be auto-graded. And then they're basically very simple assignments. So don't be worried if, I mean, computer assignment is not going to be a traditional computer assignment that you had in your undergrad, which you had to spend like 4 weeks nonstop to do it. This is a more like simpler, think about it as kind of an homework. And then most of these are available online. So if you're actually good at searching, you will find the answers to all of these. So don't get too excited if you find them. I know they exist, but the thing here is that I want you to kind of try these to kind of learn. Okay. And again, this course, you can get by on most of the things by not doing anything. And honestly, this is not thing that I would be worried about too much, because I'm here to just give you an opportunity to learn. If you learn, that's great. If you don't and you want to just get a grade, you can also get a grade. Okay. So yeah, try to kind of do it yourself. And of course, we'll check your code and see if there are similarities with others. But you can also search and find the answers. There. Okay. Just that's also something. There will be also an optional capture the flag CTF at the end. This is not going to be graded. This is just an optional thing. This is actually what was created the first time we taught the class, and some of the students actually created this. We are thinking about kind of actually expanding this a little bit with the help of some of the student groups. But it's just a fun way to end the course because it has different modules of different things. It has a cryptography modules, memory modules, side channel module, and so on. So you can actually participate on that one. I'll give you more details at the end. There's also this event called Embedded CTF or eCTF that is actually happening during this quarter. This is what has been kind of running by IEEE people. Some of them are actually here, and ACM people, undergrads mostly. But it's open to everybody, including grad students and PhD students, if you're interested. If you're interested in this to participate, let me know, and I can connect you with right peoples. The idea is that we build an embedded device. I think this year is going to be a medical device, okay? And what we're going to do is that first we're going to develop some form of security mechanisms in this. And then what will happen is this is kind of the design phase, and we need to find some flags. So we need to find some vulnerabilities in the system and then kind of fix them. The second part of the competition is actually quite interesting, because now we need to kind of switch our design with some other universities. So there's like 50 different universities participating in this, and we need to attack their device, and we need to find their vulnerabilities, and they need to do the same for us. So hopefully if you do a good job, they cannot find vulnerabilities in our design, but if you're doing a good job, we can find vulnerabilities in them, right? So this is kind of like learning about, embedded systems in general, security, and so on. So it's a very fun and interesting thing. And then you can participate. If you participate on that, you will get some participation. You get some kind of like exception for not doing the final paper review on this course. So let me know if you're interested. But it's not for everybody, right? It's going to require some time and effort. So if you're not sure about it, maybe not do it. Okay. So instead of doing the computer assignments, you can also do a research project. Okay. So the research project is kind of like a deep research project. This is just for those people who are really interested in doing some research. You need to first discuss it with me, and we can go over it. It could be done individually, or it could be done in groups. I'm open to both of them. But you don't have to do it. If you can just do the computer assignments and we're good to go. Okay. Oops, this way. And then the last part of the course elements is the final paper review. So this is actually done after the exam. You have to kind of write kind of a survey article about one of these topics that you learn in the class. The topic is your choice. You have to kind of write like a 4-page review of this, which is basically reviewing of like 4 to 8 papers together. Okay, and it's due with the finals week. I'm gonna give you more details later in the later half of the class. Okay. Grading would be kind of the breakdown would be 10% for this final review, 25% for paper presentations, 30% for computer assignments, going to be divided equally among all the 5 or 6. The final exam would be 35%. There will be bonuses for participation, but no other points for the bonuses. The grading would be absolute grading. So if you're like 98 to 100, you're going to get A plus, 93 to 98, you're going to get A. 88 to 93, you're gonna get A minus, so on and so forth. I don't think people will get below B, so most people at least gonna get some form of B. And most people usually get an A in this class, and as I said, like with some efforts, you probably can get an A easily. But again, I think the more important thing is for you to actually learn something out of this class, not being too much worried about the grade. Okay? Questions? Yeah. So the question is about the final paper review. Should it be the papers that I provided or your no, it should be your own paper. By that time, you already know what's going on in these different topics. So the intention here is that you pick a topic, a very specific topic, I don't know, like ransomware attacks on biomedical devices or something like that, and then kind of like explain it's like what's the state of the art here. Yeah. So the question is about discussion sessions. There won't be any discussion sessions, so just ignore them. Yeah. Yeah.
You mentioned we can have like a course project.
Uh-huh.
Does that count as a capstone if we're a CS student?
I believe so, yes. So somebody asked for the course project. Would that also, so you want to kind of double dip with your capstone? But yeah, you can. I mean, we probably need to kind of like make it a little bit extensive, but yeah, it counts as your capstone as well if you're an undergrad. Yeah.
Are the computer assignments auto-graded?
Yeah. So the question is, are the computer assignments going to be auto-graded? Yes. It would be just basically you submit your code, you get your grade back. Any other questions? All right, let's have a quick 5-minute break and then we come back. So, all right. So some other quick notes. There won't be any kind of reference book per se that you can use because we are talking about very different kind of topics. Discussion sessions, as I said, is not going to be required. I mean, there won't be any discussion sessions. There is a TA, but the TA will mainly work to help me with the projects. Master of Engineering, MS Master of Online students, if you have any other questions, feel free to. So everything that I said basically applies to you, except that you need to do your online exam. The presentation will be also recorded. Everything else is the same. And as I said, we take cheating very seriously. So you're not allowed to cheat, of course, in your exam, on your projects. There won't be any homeworks in this class, so that's basically it. And yeah, I think that's pretty much it. So let's actually talk about some topics. Any final questions about logistics? Very good. And then yeah, if you're on waitlist, you're gonna get into the class. And we're not going to be able probably to extend the size of the class because we are kind of at the cap size of the class, but I might be able to issue some PTs, extra PTs. So if you want to really take this class, email me and I might be able to do something. Okay. All right. So let's talk about security because the goal of this class is building secure IoT devices, right? So what is a security? That's the fundamental question. What are we trying to achieve? Anybody wants to answer this? What is security? Yeah. Preventing unauthorized access. Okay, it's good. Is that only that's the one? Do you think? can you think about other scenarios which not necessarily access is the problem, but maybe something else? For example, let's see if others have a comment. Yeah, go ahead.
Like the example that you showed where they just encrypt the data,
Mm-hmm.
like ransomware asks for money to decrypt it,
Mm-hmm.
so they might not have access to it, but they just encrypt it.
They just encrypt it. Okay, but I mean, you can still think that they access the memory content and then encrypt it, right? So they still kind of had unauthorized access to the memory, but then they did something malicious to that. So it's kind of like, if you think about any sort of attacks, it's usually two steps, right? One is kind of penetrating into the system, and then second, doing something about that. So we usually call it kind of like payload, which is the second part, and then the actual exploit that they're using, right? So in this case, for example, the payload was encrypting the data, but they managed to somehow, get inside the system, right? But yeah, that's a good observation. You had something to say? No? Yeah.
I guess like if I have someone instructing on
So someone can eavesdrop on you, and then wouldn't that still be an unauthorized access in some sense? They have unauthorized access to your communication or something, right? Any other comments? Yeah.
Could it be just limiting the amount of
Limiting the amount of damage on the system. That's the definition of security. Okay. Yeah. It's kind of more of the mitigation side, right? So we actually mitigate. We know that this is kind of inevitable, right? So maybe we can do something at least to mitigate this. That's a good observation. Yeah. Anything else? Yeah.
the use of doing some undesired behavior can potentially destroy
Yeah. So this is more generic things that this other gentleman said, right? So this is actually good to prevent as unknown or unexpected behavior from a particular user to that system that could damage the system and so on. So yeah, these are all very good observations. So generally, let me give you a little bit more. So essentially, if you want to kind of very high level explain what is security, you can say that this security is actually not protecting or preventing, but the other way around actually is achieving something. And that achievement is some properties despite the presence of an adversary. Okay. So for example, I want to read a file. I'm the legitimate user. I want to open a particular file in my computer, let's say. And by the way, when we're saying security, we're talking about cyber security. We're not talking about physical security. But some of these are analogous in physical security as well, but I'm mainly talking about cyber security. So if I, for example, want to read a file, there should be a mechanism for a legitimate user to read this file, and not for unauthorized or illegitimate users to read that file. So for example, in a very simple example, Nina wants to read a particular file in the system, okay? So that's the definition of security, basically achieving a particular capability, okay? So what are we trying to protect? And that's kind of like going back to the first comment. There are three things that we are really protecting. One is confidentiality, the second one is integrity, and the third one is availability. We actually kind of ironically call this CIA, okay? So the CIA is like basically three important things that we're trying to protect, okay? Confidentiality is kind of like the most intuitive one. That's the most thing that when you're talking about security, that's the first thing that it kind of comes into the mind, right? Like people cannot listen to what I said. They cannot read what I've written, stuff like that, right? So it has to stay confidential by a sense that only a limited group who are authorized to access that particular data should be able to, access that. Okay, that's the confidentiality part. And then this could be multiple users and could not be just the computer. It could be also communication, right? So if I talk to someone else, only me and them should be able to understand what we're saying. Anybody else in between should not be able to listen or understand what we're saying, right? So when we're talking about confidentiality, we're talking about local users, and then given that everything is now connected, we are also talking about the communication, right? So data address and data communication. The second thing is integrity, okay? So here is the story is slightly different. And here the idea is that if I send, for example, a message to my wife, right? The security of this communication method should be such that the same message should be received by her, okay? So here is not, we are not talking about, accessing what I'm saying, or not being able to read it and so on and so forth. The idea here is that I should be able, the receiver should be able to receive what it was intended to. In other words, the integrity of the data should be protected. Or for example, when I'm downloading something or when I'm receiving something, it should be the same thing that I expected to receive, right? That's why you're seeing this like hash files and these different kind of message authentication codes in order to show that this is actually the same thing that it was supposed to. And lastly, availability. So it's not about the data, it's about the infrastructure, right? So for example, as I told you, the attack to the hospital system was about data, but it was also about the availability of their system. So think about, for example, a bank that can no longer service to the customers because their servers are down, right? We're not talking about specific data. We're not talking about the integrity of the data. We're just talking about the service that being available to their users, right? And this is actually very, very important, mostly for commercial businesses, because availability is all they care, right? They need their servers to work, and many, many attacks are actually just targeting the availability. They don't care about the data. They don't care about the integrity. They just talk about availability. How many of you have heard about this attacks to the Vegas, slot machines and so on? Happens about 2 months ago. Anybody heard the news? Yeah. So there was this like very, very interesting attack it was impacted lots of actually particularly I think it was Caesar's Palace, right? So it was like this famous hotels in Vegas, which was all the slot machines were kind of out of order. They were not working. And then since they actually attacked the entire system, even the guests in the hotel was not there, the cards readers for the doors wasn't working. It was a huge mess. And think about like a casino, like a big casino, hundreds, thousands of dollars are being kind of transactions every minute. And now the system is down, and there was like huge, I mean, definitely go and Google it. There was like kind of staff kind of paying cashes to the customers. It was like a huge mess. And availability is kind of like a very important thing there. Apart from availability, there are also other important metrics that are not necessarily these three CIA things, but it's also equally important. The first one is privacy, and the privacy is a little bit different than confidentiality. The privacy is more of like who really authorized to kind of do things in my data, right? So confidentiality is more of like a very well-defined thing, as in like, A and B is only two that has to access this data. But the privacy is more of like who can see what part of my data and for what reason, right? We're not going to talk much about privacy in this course. Previous version of the course, we actually talked a lot about privacy preserving computation and stuff like that. But I removed those and replaced it with some other things. If you actually go way back, I think spring of 2021 offering of the course, you will see lots of lectures on that. If you're interested, definitely you can go and check them out. So this privacy is one thing. Another one is authentication, and authentication is kind of a means to do things. For example, if I want to protect my integrity or confidentiality, one of the very first things I need to do is that I need a mechanism to authenticate myself, right? So lots of this course would be about various forms of authentication, actually. And then the three bullets in the later part of this slide is talking about things that are relevant to the security, but they're not security. So reliability is another thing. And the difference between reliability and security is that reliability is talking about the availability of the system under natural problems. Okay, so for example, if the temperature suddenly goes up and down, if there is a big, I don't know, shake, there is, I don't know, a natural disaster, there's an earthquake, there's things like that. Can my system still work properly, right? So, and that's the reliability aspects of things. And many things needs to be reliable, but being reliable doesn't mean secure, or being secure doesn't mean reliable. And the reliability also changes differently from different applications. If you want to send a spaceship to the Mars, it has to be very reliable, versus if you're building something for your class projects, it's probably not going to work, right? So it's just very serious form of reliability that you need to be worried about. We're not going to talk about reliability in this course, but just keep that in mind. Another important thing is fairness. And fairness here is that we're providing service in some form of fair manner, and then fair is actually like a very open-ended and high-level concept. You can define fair at various different cases, right? So you want your system to be reliable, you want your system to be secure, and you want your system to be fair as well. And again, it's a like very close topic to security, but it's not security. So they're mutually exclusive. And then finally, explainability. And this explainability part is actually kind of becoming more and more important these days because of the rise of AI and machine learning, that you want to be able to also explain what your system is really doing, why it's making these decisions that it's making, right? And again, your system needs to be secure, reliable, fair, and it also needs to be explainable in most cases so that you can actually understand why it's doing what it's doing. And for machine learning, for example, particularly, this is the biggest issue because we not really know why my camera cannot detect this particular object. We just know that it doesn't detect it, but we cannot explain why. Versus if you're probably using some form of like rule-based or something, you can actually point it to the like bug in your code, right? So that's the difference. But anyway, we're going to talk about these three and a little bit of authentication, but we're not going to talk about these others. But just keep in mind that they're relevant. All right, so now that we know what is security and what we're protecting, so we want to achieve some capabilities, and that capability is either confidentiality, integrity, or availability, all of them or some of them, okay? So how do we achieve that? So for example, let's go back to kind of Nina wants to read the file. In order to achieve this, we're going to implement some policies, okay? So for example, we're going to say that the policy that we're going to use is that everybody who reads this file needs to have a password. They need to type in a password, and if they do, they can read this file, okay? So this is how we're going to achieve this security property that we want, that only particular persons can read this file, okay? But then the interesting questions and interesting, discussion that comes out, and this is how do we actually implement this, okay? On paper, everything is secure technically, because I can say, oh, let's require passwords and then we're good, right? But this require password is actually an application itself, right? How do we actually implement requiring a password? How do we save those passwords? How do we share those passwords? These are all implementations themselves, right? So it's not straightforward for a policy. We need to actually implement that policy. And 99% of the problem in security, interestingly, is actually because of that implementation. It has nothing to do with the policy. The policy actually works great. It's perfectly fine. The reason that our system is not secure is because we're not properly implementing that implementation, okay? And then not only implementation, but also enforcing, because we need to make sure that this password checking is always enforced at the beginning of the system, when it's booted, when the power goes up and come back, and all those scenarios. Like there are many, many different scenarios that you want to make sure that this enforcement is always there. And the interesting thing, as I said, is that these are the two main things that's the number one cause of our systems not be secure, okay? And then one thing that someone says actually in the back of the class is, it's not just about achieving security, because what we have learned is security vulnerabilities and attacks kind of inevitable, at least for now, because we kind of like be very negligent about security for a very long time. So it's not going to be like tomorrow we can solve all the security problems. Some of it we may never be able to fix them, okay? So we have to live with them, okay? In order to live with them, we need mechanism to at least detect. We at least need to know whether my system being attacked or not. And I need to have some form of a plan, contingency plans, how to react to an attack. For example, if somebody hack our systems, what is the right thing to do, right? It's kind of like a pandemic, right? So if the virus kind of spread, what should we do at least to kind of, damage control, right? So this is like also an important part, and we're going to talk a little bit about things like malware detection in the class and so on and so forth. All right. So now going back to the achieving security, as I said, the first step is defining policy, and it's very clear that if your policy is wrong, then your system is basically broken, right? So at the very least, what you can do is that defining correct policies, right? Because as I said, usually this part is not a big part, but if you get this part wrong, then your entire system is wrong. That's very simple, right? So we usually, define these policies based on some principles, okay? So policies is not like a mathematics that I can prove it to you. It's mostly based on experience, the domain specific knowledge, and then of course some theory, but mostly it's just non-theoretical, okay? So again, like, requiring password. Can I prove that this is the only way that we can achieve security? Maybe, maybe not. For some problems I can, for some problems I cannot. So how do we actually come up with these policies? As I said, this is more of based on experience and based on some things that we know these are good security practices, which we call security principles, okay? So what are those security principles? There are actually kind of like 8, 9, or 10 of them that I'm going to talk about one by one. We have a little bit of time, so hopefully I can finish this. All right, so let's talk about those security principles. Any questions so far? All right, the first principle, this is the very important one, and that is the threat model, okay? So threat model is basically kind of like answering these type of questions. What are the attacker's capabilities, okay? What are the system's capabilities? What are the system weaknesses, right? And then if you want to go a little bit, more details, on the attacker side, what does the attacker already know? For example, the attacker knows that, people, I don't know, accessing, let's talk about the casino scenario, right? The attacker knows that people kind of come to this casino, they kind of like put the money in, they kind of play with this and so on and so forth. The attacker probably also knows that there are lots of people in this casino. Some of them may not be necessarily very expert, or they might be drunk, so they can be exploited, and so on and so forth, right? The second question is, what level of access does the attacker has? Does the attacker can get very, very close and have physical access to the device that they're trying to attack? Or are they kind of thousands of miles away, maybe in somewhere in Asia or whatever, and they're trying to attack our systems? Is it like this is a high-end security server that we installed in, I don't know, White House and nobody can go? Or is it a system that's, I just installed it on my computer in my office and everybody just kind of like walk by, right? So these are very, very different scenarios. And the reason for this is that this gives level of different capabilities to the attacker. As we actually talk about real attacks very soon, you're going to see how this big of a difference is important. Because many of the attacks, for example, cannot happen unless the attacker has very, very close physical proximity to the device. In that case, I don't need to be worried about that type of attacks if I know that my system is, for example, in a safe room, right? The third thing is what the attacker really tries to achieve. Are they trying to attack confidentiality, availability, integrity, any of them? What is specifically is the problem? And then finally, what are the resources for the attack? Is the attacker just one person? Is it the government? Is it a big company? Who is going to attack me, right? If I'm a private citizen, probably like, I don't know, Russian government ain't going to attack me. But if I'm like, a high-end, military rank in, I don't know, US Army, then I'm very likely to be attacked by other governments, right? So I have to be very careful. Right? So that's why, like, people at the sensitive areas, they actually have lots of protection versus, normal people probably just have, it's a laptop and a PC and so on and so forth, not really protecting themselves, right? If I'm, for example, protecting my lab's website, maybe it's something I need to be a little bit more worried about. If I'm using my personal website, maybe less, right? So these are kind of like resources. And again, you're going to see why attackers' resources are going to have an impact on the system. And then on the threat model, continuing the threat model on the user level and the user sides, we also need to answer some questions. Things like, what needs to be protected? What level of existing protection do we have already, right? Do we have physical protection and so on and so forth? A third one that we're going to talk a lot in this course is what can we trust already, okay? And we usually call this a trusted computing base or TCB. What part of our system do we actually trust already? You might be surprised, but this answer might be none. So like nothing we can trust. There might be very, very tiny piece of code that we can trust, so on and so forth. You're going to see how this actually play a role. And finally, human factors on the user level, okay? We need to understand whether human factors play a role. For example, in this Vegas casino example, the reason that the hackers managed to attack the systems was purely human mistakes. So this is called social engineering. So it's kind of like this, that somebody like call you and say, oh, I'm the manager of this group and that group, change the password of the website. And the poor guy who's kind of answering the phone has no idea whether this is the right person, this is really the manager of that group, or is it just some random hacker that's trying to kind of get my system to be reset? And as I said, if you can exploit this kind of human factors, for example, if this is a new guy just hired, they may not really ask a question, who are you, or authenticate yourself, and so on and so forth. So they might actually reset the system. So that's exactly how they managed to kind of infiltrate into the two-factor authentication mechanism that they have for this particular company. They managed to get the password to log into their systems, and then boom, they changed everything, and they have millions of dollars of loss for the company. Okay, so human factors are actually very, very important thing. And then following the right protocols as a human is also very important. One thing that you probably I want you to kind of get out of this course is following the right protocols of security is always an important thing to do. Okay? So this is the first one, threat model. Any questions? The second thing is the trade-offs or the overheads. One thing that you will see is that security is not kind of an isolated thing. It's always part of a big system. So whatever security solutions that we come up with, it has to be meaningful in the sense that it has to have minimal overheads. It's hard to achieve zero overhead, but it's meaningful to achieve minimal overhead. When we're talking about overhead, we're talking about cost, performance, power, stuff like that, right? So for example, if I come up with this mechanism that makes my computer 100 times slower, but eliminates all the security problems, is this a good solution or a bad solution? I don't know. Anybody who thinks that this is a good solution? Nobody, and nobody thinks that this is a good solution. In fact, there might be a good solution. So for example, if it's a nuclear, I don't know, reactor, do you think that if I have a system that is 50 times faster, but there is like 1% chance that it's going to be attacked, versus if I have a system that's 100 times slower, but there's 0 chance it's going to be attacked, which one would you choose? It's the slower one. So it's very, right? So it's not like a one answer that fits all. It really depends on the scenario. And you have to understand what is that scenario. Like, is this security solution going to go into kind of a mainstream iPhones, or is it going to be installed in a very highly sensitive system? Right? And then there, kind of like the overheads change, right? So any sort of principles that we come up with, any sort of policy that we come up with, we need to understand these trade-offs in this overheads, okay? Like 100-factor authentication may not be good, but maybe 2-factor authentication could work, right? So things like that. And then it has to be convenient and user-friendly, right? So like, again, back to 2-factor authentication, people don't like it, but they kind of live with it. maybe if there's a nicer way of like being able to sign in without really like every time you have to kind of check your phone and so on, maybe that would have been nicer, right? But still, it's kind of like these trade-offs that we need to live with. The third one is that, defense should be usually multi-layer, okay? So we typically don't just do one, we typically add layers of security together. The reason for this is that if the attacker managed to kind of find a way to penetrate and eliminate one layer, there will be other layers that kind of helps the system to stay secure. We call this defense in depth. Okay, so for example, if somehow they find the password, there's still like, this two-factor authentication is doing this, right? If they know the password, they still cannot log in because you still have possessions of your phone, for example, right? So defense's depth is actually helping you with this, okay? The fourth one is what we call a principle of least privilege. And the idea of least privilege is that you have to give minimum amount of access possible to any user. And this minimum is the minimum that they can do something meaningful. So for example, if you download an app, by default, the app does not have access to your camera, does not have access to your microphone, photo gallery, etc., right? But for example, if this is a Zoom application, obviously they need to access your camera, right? So the principle of least privilege says that my operating system should treat everything as, okay, nobody can access anything unless they really need to and they go through a process, they go through a protocol, okay? So minimum amount in order to do something meaningful. For Zoom, without camera, you cannot do anything meaningful, so we have to let them to access the camera. But for Spotify, you don't need to give them access to your camera, so you don't, right? So this is kind of like the idea of the principle of least privilege. The fifth one is what we call distributed trust, okay? This is kind of similar into multi-layer defense, but this is kind of more at the distributed level, which means that we usually have to distribute the trust so that no one person has the complete access, okay? This is specifically very common in military systems, that if you want to launch a missile, it's not like, oh, you press this button and boom. You have to trust like 4 different buttons, 4 different keys, various different places so that you can actually launch that missile, okay? And the reason for this is that if somebody kind of like, being hacked or being, compromised, the attacker cannot still successfully launch their attack, right? So distributed trust, and again, two-factor authentication is kind of the idea of distributed trust. There is one that is password, maybe in your computer, there's also one in your cell phone, and the attacker needs to access both of them in order to successfully launch an attack. The sixth one is what we call ensure a complete mediation. So this is more on the defense side. So if I want to fix something, I need to make sure that my solution is complete, which means that I cannot solve like half of the problem. So if this is like a big hole here, and then there is another hole here, I cannot say that, oh, I find a solution for this. Nobody's going to care because there's still this other hole that the attacker can access and attack, right? So what we do is that this complete, and then I made this complete uppercase to kind of emphasize that we have to make sure that all entries to the system is protected and secure, because basically we are always secure as our weakest point, right? So we need to make sure that every part of the system, network, hardware, software, every part of software, every part of hardware, they're all secure at the same rate. Otherwise, there's no point. And then this one is actually something that, those that were not familiar with security, it's very counterintuitive to them. We call this security by obscurity, or the Kerckhoff or Shannon theory, which the idea is that you never should rely on obscurity for achieving security, okay? So you cannot rely on the fact that you know something about your implementation that the adversary does not know, and that's the part that gives you edge. That's the part that's going to give you security, because that's not the right way to achieve security. By obscurity, you should never achieve security. The way that you should achieve security is based on some principles. So next week, we're actually going to talk about cryptography algorithms. We're going to talk about things such as RSA and AES. These are very well-known algorithms that's used in all the standards commercial systems. Everything about AES and RSA is known. You can actually see the line by line of the code of AES. You can see the actual implementation that's being used on your systems. So the code, nothing about AES and what it does is unknown or obscure. The only thing that is private and secure is the key, the private key, and that's the part that we're gonna be used in order to build this big system of this complex system of cryptography. Okay, so you never should rely on obscurity. Everything about your system should be open, should be known. Of course, you may want to do obscurity because of financial reasons or kind of IP reasons, but for security reasons, it's better not to have anything obscure. Okay. Another one is what we call use fail-safe defaults, which means that if my systems fail, I still need my system to be secure. An example of this is that, if the power goes out in this building, do you think the default should be the doors should be locked or unlocked? Locked or unlocked? Unlocked. Why?
Right now, the power goes up, we lock inside.
Well, I mean, you can. Let's assume you can go outside. Yeah. Locked. But wouldn't lock be inconvenience because now the power out and someone wants to go in? What should they do? The power is out. There's no way that you're coming in, right? But the system, but the door is locked.
They'd have to reboot, basically get the power on.
Yeah.
So that's an engineering design.
Yeah.
They'll probably put the power shaft outside, reboot it, and then come inside.
Yeah, maybe something like that. So generally, the idea is, again, it's going to be a trade-off between convenience and security. And what you will see is that in many cases, security is kind of opposite of the convenience, unfortunately. You have to make them as close as possible. Like, for example, say, okay, let's think about this and make it more convenient. But at the end of the day, if you have to choose between security and convenience, you have to see which system is this. If this is, again, a very highly sensitive system or a building, then if the power goes out, I don't care. I want this door to be locked. Even if the US presence wants to go in, maybe they can wait, right? Versus, I don't know, if this is kind of like a gym or something, maybe it's not a bad idea to make this unlocked, especially if the power goes out multiple times a day. You don't want to piss off, your customers or something, right? So this is kind of a trade-off. But for secure systems, you definitely want to do fail-safe, which means that if my system is failing, still has to remain secure. That's the idea. Okay. The last one before last is the principle of isolation, which means that we have to isolate system as much as possible. We don't think about IoT security. If I don't connect it to the internet, I'm probably very safe, right? So if I can, I should, right? If I can isolate my system, I can, but of course, the story is I cannot isolate things as much as I want, right? I need to interact with the untrusted word and so on and so forth, and the results, my system going to be compromised. But if you can isolate things, you should, okay? And lastly, we should use simplicity. If the system is simple, it's much more easier for them to be secure, right? Think about this. If the system is simple, it's very hard to break. Simple things tend to stay for longer times because there are less things that potentially could go wrong. So same story applies to security. If your system is as simple as possible, maybe it's 10 lines of code, it's much more easier to verify this 10 lines of code versus if you have a million lines of code. But again, things are not that simple. You need more features, so you add more things, and your system becomes more complex as the time moves on. But if you think about policies, think about the simplest policy to achieve a particular security. Okay? All right, so these are your principles: threat models, trade-offs, multi-layer defense, least privilege, distributed trust, ensure complete resolutions or mediations, do not rely on obscurity, use fail-safe device, use isolation if you can, and use as much as simplicity that you can. This is the kind of your blueprint when you're coming with a policy. Okay, so whenever you kind of like, go and start to like doing your own security firm or whatever, and you need to start with policies, this is your principles that you need to use. Okay, and almost everything that we use using some form of these principles. Okay, and how do we go from here to actual policies? Again, that's not really straightforward. That's more of like engineering problem, really. Okay, questions? All right. So wrapping up, so what are the challenges? The challenges, as I said, is the implementations, okay? So all these, they're pretty straightforward. We probably can achieve all of these things. The problem, though, is that in order to implement this, we're going to introduce lots of box store systems, unfortunately. And those are the problems. Those are the main reasons that our systems are not secure. Not these principles, but those are the bugs that are kind of create these issues. Although there's another one that we call zero-day vulnerabilities, which means that when we were designing the system, we were not aware of a particular threat, okay? So we're actually going to talk about this a little bit more with some examples. So zero-day vulnerabilities is things that we don't know at the moment that our system is not secure because of them. Later on, somebody will attack our systems, use those, and then now we're going to realize that, oh, we should have actually thought about this when we were designing the system, okay? And the interesting thing about security is that security is a dynamic thing. It's thinking about it solving a puzzle. So at the moment, this puzzle might seem unsolvable, so you can base everything on that. But the moment that, somebody is smart enough solve that puzzle, then everything that you build on top of it, it's gone, right? That's why, for example, we are based on cryptography systems based on some hard theory problems, like RSA problem is based on factorization. I'm going to talk about it next week. And then the current assumption is that factorization is a hard problem to solve. Computers cannot factorize things in a short time of, in a short amount of time. It takes months or years for kind of factorize that. And based on that, we were going to build our crypto system. And the interesting thing is, like, for example, if you have a quantum computer, the quantum computer can factorize things within a few minutes, okay? As a result, all of our RSA systems and all cryptography that we do is kind of broken by that. So you can think about this is that at the moment, these are unknown things. In future, they may not. Yeah. Well, I mean, for quantum, no longer is a 0 day. So I don't think there is a name for it. So that's why now there's lots of, for example, research on post-quantum cryptography, right? Because now quantum is a known. But think about 70 years ago, for example, 50 years ago, right? At that time, it was an unknown problem. So quantum now is a known problem, although the not known problem about quantum is actually how to build a quantum computer that's kind of capable enough. Because in order to break RSA, you need a quantum computer with like around 1,000 qubits. Now we're at around 100, but we're getting there. But there are many other unknowns that we don't know. And then another problem is the unknown problem, which means that we don't know what we don't know, right? So we don't know, if I build this, I think that, okay, I spent a lot of time and I think this is secure, but how do you even know that's the things that might happen in future, right? So this is the big problem. So this is the second challenge. The third challenge is, of course, the overhead and complexity. The fourth one is the large attack surface, as I said, because, for example, think about, again, as the cell phone. The cell phone is like at various different places is actually can be attacked. A user, a human factor, network, so on and so forth. And then sometimes the policies might not be enough. Maybe we're actually not doing a great job in policy. So this is also possible. Okay. All right. So kind of like, wrapping up here. So the kind of like the takeaway message from this like set of slides is security is a cross-stack problem. So it's not a hardware problem. It's not a software problem. It's start from hardware and go all the way to the software. And in some sense, it's everybody's problems and it's nobody's problems, depending on who you're asking. And as a result, in order to understand the security, we need to have a kind of cross-layer approach. And that's why in this class, we kind of talk about all of these things, okay? In order to kind of understand a little bit of everything. But of course, you need to spend a lot of more time in order to really become an expert in any of these, because these are very, very complex materials. So yeah, what is out there? There's, lots of people works on the theory aspects of security. There are lots of people working on the crypto and crypto implementation. Of course, hardware and hardware primitives. This is kind of my area that I'm working on. There are a whole bunch of people working on operating systems. There are a whole bunch of things within the operating systems for security. Network, of course, another big thing. Programming languages, software application, internet. There's all various aspects of computing stack that all of them there are people who are actively working on the security aspects of these things. Some of them directly, some of them indirectly. Okay? And then we will talk some of these. Now we're going to talk a little bit about crypto, hardware, a little bit of these, a little bit of this, but not these things, unfortunately. Okay? Yeah, these are some relevant courses, just FYI, if you're interested, just Google them, you will see some similarities or a little bit of difference. Yeah, that's in the presentation for today. Thank you, guys.